Hey guys, so we are talking about solving equations in one step. So equations that it only takes one step to solve, and I thought of what I hope is a cool way to explain how this works. Okay, so let's say we have these two baskets of fruit, and they are equal. They have the same amount in them, 2 oranges in each one. So if I were to put them on a scale, to like weigh them, they would be perfectly balanced. Same stuff in each one. Okay, equations work this way. So whatever's on one side of the equal sign is the same thing on the other one. Okay, so this would be a true equation, 2 equals 2. Okay, so we're gonna mix it up a little bit. I'm gonna add one of the oranges to the other basket. So this would throw it off, okay? This would not be a true equation anymore because this one has more. All right, but we have a mystery item. Don't know what this is, but this mystery item, when I put it in the basket, it takes our equations from unbalanced back to balanced. Okay, so now what does that tell you about the mystery fruit, I guess? Okay, what it tells me is that if it balances these equations, if it balances these baskets, then however much that mystery item weighs should be the same as some of this fruit. So we got to simplify things a little bit so I know exactly what that mystery item weighs. Okay, so how would we do that? Well, if I want to know just what one thing weighs, I could take away one of the oranges. So now this is by itself, but what happened? If it was balanced before, I just took something out of this side, so I'm off kilter. How would I get it back to balanced? Okay, and that would be to take one out of the other side. Okay, so what I did to this basket, I did to this basket, and that caused me to come back to even. Okay, so they are now balanced. So now I know that my mystery item weighs the same as 2 oranges. Okay, there's several ways that we could do this, and when we get to negatives and multiplying and dividing in there, it gets a little complicated with the baskets, but I'm going to try to translate the same problem to numbers and show you how that math works. Okay, so let's write it out. 3 oranges equals 1 orange plus mystery item. I took away 1 orange from each of them. Well, I need new fruit. That gave me that the mystery item was equal to 2 oranges. Okay, we'll look at some examples where we don't have baskets of fruit. So as we look at these equations, I want you to remember to keep your equation balanced. Just like with the baskets of fruit and the oranges in it, whatever you do to one side, you have to do to the other. Okay, so our first example is pretty simple. X plus 5 equals 20. And what I want you to do is just draw a line down that equal sign. And we're going to write what our goal is at the bottom. So we want x to equal something, just x by itself. So how we make that happen is we see that we're adding 5. So to get that to be just x and not x plus 5, we've got to take away or subtract that 5. We got to stay balanced, so we'll have to do that over here to the 20 as well. Okay, then we just do that process, do the math. Positive 5 minus 5 is 0. So it goes away to just x, which is what we wanted. And then 20 minus 5 is 15. This means that our answer is x is 15. Okay, what about subtraction? So in this case, again, I want there to be just x equals a number. Right now, I'm taking 3 away from x. So if you think about a number line, if you're on -3, how do you get back to 0? If I'm taking 3 away from something, how do I get it back to even? And that would be to add it back. So in this case, we're going to add 3 to both sides and do the math. Negative 3 plus 3 is 0, which is what we wanted. 17 plus 3 is 20. And you can always go back and make sure that you're right by checking your answer. So I could take that 20, plug it in for x, and say, does 20 minus 3 equal 17? And yeah, of course it does. Okay, now let's look at solving equations still in one step, but with multiplication and division. So in the previous 2 examples, we were using addition to undo subtraction and subtraction to undo addition. Now we're going to use division to undo multiplication and multiplication to undo division. This relationship is called inverse operations. So addition and subtraction undo each other. They are inverse operations. Multiplication and division undo each other. They are inverse operations. So here's our example. 3x or 3 times x equals 21. Still our goal is for x to equal a number. So this x that I'm trying to figure out right now, I have 3 of them. And I'm trying to figure out how much just one would be. So if I have 3 of them, how do I get that 3 just to 1? I divide by 3. So that division is undoing our multiplication. Of course, we have to do it to this side, and we do the math. So 3 divided by 3 is 1, which is good because I just wanted 1x, and now I have that. And 21 divided by 3 is 7. Okay, in this example, we have division. So it's like I have a fraction of x. I just have a tiny piece of it. I don't have the whole thing. And I want the whole thing. I want just x equals a number. So if I have a fifth of it, or if I'm dividing it by 5, how do I get it back to normal? I times by 5. So a fifth of x times 5 would just be 1x. So those kind of cancel each other out. And 4 times 5 is 20. And again, you can always check by plugging that number back in for x. And so we would say 20 divided by 5. Does that equal 4? Yes, and that's how I know my answer is correct. This example looks a little bit tricky, and you can treat these like a one step with this little trick. It's multiplication, so 3/2 times x equals 6. And so it's really saying 3/2 of what number is 6. And a way to figure that out really quickly is, it's multiplication, so we are just going to divide by 3/2. But if you remember, dividing a fraction is the same thing as multiplying by the reciprocal. So in other words, if you just flip the fraction and multiply, it cancels itself out. But always remember, if we did it over there, we have to do it over here. So I'm just timesing by 2/3 to both sides. When you multiply a whole number in a fraction, just multiply the top. So this gives us x equals 12/3, or 12 divided by 3, which is 4.